Welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to respond to a question in Shape and Space 7, Exercise 3 star, and question number 10, which is talking about three circular pencils, each with a diameter of 1 centimeter, are held together by an elastic band. What is the stretched length of the band? We are talking of this pencil, circular pencil, and this other pencil, and this other pencil, each one of them with a diameter of 1 centimeter. And you can see the rubber band is tying around the three pencils. This is the elastic band. So the question is, what is the length of the band? In other words, now that we have this as a center of one circle, this as the center of the other circle, this as the center of the other circle, when we join the three centers, as you can see, then we form a triangle. In fact, an equilateral triangle, whereby this angle is 60 degrees, that is 60 degrees, that is 60 degrees, and that is 60 degrees, by the virtue of this side being a half, being the radius of this circle, plus a half, that is 1 centimeter, and this is 1 centimeter, and the other one is just 1 centimeter. So having said that, we know the property of radius. We know how the radius connects with the tangent of the circle, because the rubber bands forms the tangent of the three circles. So if we can produce this radius from this particular point to this tangent, we know that radius meets a tangent at right angle, so that is 90 degrees. At the same time, this is 90 degrees. This is also 90 degrees. This is 90 degrees. This is 90 degrees. This is 90 degrees. And you can see this is also 90 degrees, and this is 90 degrees. You can see this is also 90 and 90 and 90 and 90 degrees. We have three rectangles. This is one of the rectangle. There's another one here, and there's another one there. So the most important part of this question is to know the length of that rubber band from this particular point to this particular point. And how do we know that? First of all, let us know this by itself is 60 degrees, this is 90, and this is 90. So from 360, we have 60 plus 90 plus 90, that is 240, and 360 minus answer is actually 120 degrees. So the angle that remains here, this one is 120 degrees, and they are all equal. If that is 120 degrees, this is also 120 degrees, and this is also 120 degrees. Let us calculate the length of this arc, which is going to be 120 out of 360 times 2 pi r, because it is part of the circumference of the circle. 2 pi, the radius of the circle is a half. And as you can see, this is by 2 by 2 by 121 by 123. So we are talking about a third pi, or pi over 3. And because they are three such similar arcs, there is this one, and there is this one, and there is this one, so times 3, which is equals to pi centimeters. Pi centimeter, pi is actually equals to 3.14. This is 3.14 centimeters. We are done with the arcs, the three arcs. Now we need this stretch. which is also equals to this. And you can see this is half because it is the radius, and this is also a half because it happens to be the radius of the circle. So the whole of this line is 1. So from here to here is 1 centimeter, 1 centimeter, 1 centimeter, and 1 centimeter. And because we have this, that, and that, the total length of the rubber band is 3.14 plus 1, 2, 3 plus 3.00, which is 6.14 centimeters. And that is the length of the rubber band, and that is the answer to that question. Thank you and see you later.